We have this topic over here called a binary adder, which is usually the other name is they call for this is 4-bit adder, full adder, 4-bit full adder, or another thing is subtractor over here. In this you can see that they are arranged in parallel way. So understanding this is not that difficult, but you have to like some things you have to like by heart, like kind of by heart here, because explanation directly you cannot understand over here. Same thing, same logic of full adder itself. Few things just these are basic how we like represent this 4-bit binary adder. So as you can see here, we add these two things. So adding A0 and B0, we will get a sum. So usually we know, right? So if we add in adding binary, if we add something, we will get one sum and one carry. So for A0 if we add, so both are knotted, so we will get S0 as sum and C1 as carry. So that carry will go here, right? So I have that for that is shown with one arrow mark. Then A1 B1 if it get added, we will get S1 as sum 1 and we will get one carry 2. That carry 2 goes here. A2 B2 if we add, we will get S2 one carry 3. Similarly, we will for at the end A3 B3 will get S3 as sum and C4 as carry. So now the same thing, this equation here we have represented here. So adding A0 and B0 full adder. So from outside we are giving one carry in, C out, okay, I mean C0. From ground we will get that. So I will show that in the next page. I will show that where it comes. So here C1 as carry. So from here we will get S0 and here we will get so this equals to 0, don't go there, okay, that from values we have written that. So here C1 carry, C2 carry, C3 carry, and it goes C4 goes out. So sum 0, sum 1, sum 2, sum 3, same thing, A0 B0, A1 B1, A2 B2, A3 B3. So now we have to draw this, this is the same logic diagram which we have in our binary adder. So here what we have to do, so multiplication we are representing as GI, and for addition where it is getting like exclusive things are there, where there we are writing PI, okay. So for C in we are taking usually as CI. So here and we have to understand here, see, so A exclusive B is taken as PI, so here what will get PI exclusive CI, and A into B is taken as GI. So here you have at the end you will get AB instead of AB will have GI plus PI is nothing but A exclusive B into CI. So just see here once again I will say, instead of A exclusive B we have PI, instead of AB we have GI, that's it. And so in place of C in you will write CI. So why here I are there, because it will change from CI from C0 to C1, C2, C3 up to here we have 3, right? So till there it will change. So let me explain that here for you. So see here, usually CI plus 1 is equals to GI plus PI into CI. So this was your carry out, right? So now if C of 1, if I is 1, so what it will be, C0 G0 plus P0 C0. How we get G0 plus P0 C0? So usually it is I plus 1, right? C of I plus 1 is nothing but 0 plus 1. So here then only we will get 1 here. So everything will be 0 over here, okay. So if it is 0 we will get here 1, if it is 1 I mean yeah, so I plus 1. So here if C of I, so I mean C of 1 is over here, so you will have 1 minus I mean whatever number is here, that minus 1, so that will be here all 0 here. So see here now one thing to be careful, here only substitution works. So C1 value you got over here, so C2 is equals to G1 plus P1 into C1. Now here you cannot leave it as it is, so you know the value of C1 which you got here, so you have to substitute that value here and multiply. So from that you will get one value, that is your C2 value. Similarly C3 is equals to G2 plus P2 into C2. So C2 value here you have got, that value you have to put here and substitute, you will get one equation, this kind of equation. For this equation you have to draw your logic diagram and just write here whatever you are getting. I think this is C1, C2 and C3, like that you have to write and finish. This is your 4-bit binary adder. So similarly using one NOT gate here for you have here binary subtractor also. So here what is this, just here NOT gate is coming here, okay. C in, this is also your binary adder itself, but you have your one NOT gate over here. So in question they might specify something over this, so it's not that difficult. Usually I know this topic goes like this thing goes above head, but here whatever I am just saying, just try to understand that, and whatever question you get, if you know this kind of thing is coming, just put this whole thing as an answer over there. So see here, same thing, same diagram. So C out is going here, just not get you are getting. So equals to, no need to write this equals to and all, because that if we give one value here, right, we have just giving here a naught. So suppose if we give value as a is 0 over here initially and b is 1. So if you add 0 and 1, what you will get? Sum. You have to write that, and then what carry goes like that, you have to keep giving and coming. So binary subtractor thing you have here. So another thing, so see here, this is one kind of important thing which might be asked. So even I don't know what it is called, but see this diagram. So here you have exclusive thing here, instead of normal NOT gate, you have one what is it, XOR gate, 2 input XOR gate, in which one input is your carry in and another input is your B naught. For adder you will be having carry in and B naught as your input. For subtractor, instead of carry in you will be having borrow in, that's it, B in you will be having. So see here, if it is for subtractor, 0 exclusive 1 is 1 and 1 exclusive 1 equals to 0 and B exclusive 1 is equals to B bar, C out equals to 1. So this thing just try to remember. So as you can see here, C in is 1 initially. So if it is 1 here and it is 0, 0 exclusive 1 for adder. So here I mean B exclusive 0, you will get B itself, okay, no matter what B is. So you will get 1 itself as an output. So like I said, B exclusive 0 is B. So 0 exclusive 1 you will get 0 itself, and here you have to add 0 and 1. The sum will be 1. Why sum is 1? 1 plus 0 is 1 itself. So now the carry will be passed here. So what carry do you have here? That will be passed here as here carry, again it is passed as 1 itself. Same thing again. So B1, so 1 exclusive 1, that will be 1 itself again. So 0 1, again your sum will be 1 and the carry is passed as 1. Now again you will be having here B2 equals to 1. Now here you had A as 0 and here you had A as 1. So either among this, either 1 was 0 and 1 was 1, so around you got sum as 1. But here your A is 1 here, okay. So see here 1 0 1 0, and here B is always B also like 0 1 1 1. So only here you have B as 0, remaining all place 1, and carry is 1 throughout the places. So see here, now you have 1, here also 1. So what you will get? 1 exclusive 1. For adder you will get 1 itself. So 1 plus 1, so you won't get carry, you will get 1 and you will get sum as 0. So sum why, how sum is 0? You have to see that full adder video again. And again here you can see you have A is 0, so whatever B it is, if it is 1 you will get that itself. So you have to write like this, and you can say sum is 0. Now what you have to do, the thing here is you have to change the carry into 0 now. So if you change that to 0, this value of sum will change, okay. So I didn't write here, so you just have to change the value of carry is, instead of 1 write put 0. So see here, 0 exclusive 0 you will get 0. So if it is 0 and it is 1, 1 exclusive 0 you will get B. What is B? That only will reflect here. So suppose it is 0 here now. So 1 exclusive 0. So what is B itself will come, okay. So B exclusive 1 will be your B bar, B exclusive 0 will be your B. So actually what will be happening here, if it is 0, so B exclusive 0, right. So that will be here. Now B exclusive 1 you will get B bar like this. So for adder it is like this, for subtractor you will use this. So for adder, like you say C in 1, just put 1 0 and C, and instead of for subtractor you put whatever this thing it is said. So if it is like this, for subtractor change, instead of C you put B in like that, and same thing you will get here, and instead of sum you will write difference. Just you will change the terms, and same logic you will put here. Once again in simple terms let me tell you, remember the diagram, only the thing will change here is for full adder it is like this, same to same. Here you can change the carry for initially 1 you gave, if you change the carry to 0, whatever you are getting your sum you have to write. Then what you have to do, same thing draw, instead of FA write SA subtractor, FS you have to write full subtractor, instead of carry you will write borrow, instead of sum you will write difference. That's the only thing. And see, use this for your subtractor and use this for your adder and just finish it. So this completes your combinational circuit. You can just see some solved answers on this type of questions. There is the last binary adder and binary subtractor. So that's how you do this, and this finishes your combinatorial circuit. And coming up to sequential circuit, just see the definition. They might ask differences or something. I am not going to like explain about that now itself, because I am going to skip the topic. If it comes, I will go for the OR option. So that's it, finishes your second module. So there is nothing extra for me to teach her. If there is anything you want to ask, or if you had doubt in any explanation, comment as soon as fast you can below, so that I can make it fast and upload, because it takes time for me to upload. Everything is managed in my own single phone. So for processing and for uploading, it takes additional time. So for one video, if it is completed, for making I need time, then half an hour to 1 hour for processing, again half an hour to 1 hour for uploading. So 2 hours goes here itself, even though all the videos are recorded in advance, but for uploading it's taking some 2 to 3 hours. So better you